Imagine this, you turn on your camera and in real time your face becomes more clear, sharp and restored. No waiting, no extra steps. In this video I'll show you how I built a real-time model based on GFP-GAN. Explain how it works. In another video I already explained why GFP-GAN is so useful and how you can use it step by step. You haven't seen that one yet? Trust me. If you watch that video, you will understand why this model is game changer. This model has a simple structure. It's easy to run, free, optimized and also customizable. You only need to download the files from the repo and run them. Later in this video, we will go deeper into customization and the code structure, which might be interesting for some of you. To better understand how the code works, you need to know what role each library and sub-library plays. These are Python built-in libraries, each used to make the project better. Argparse gets setting from the user before running, like video source, model input size or output path. Without it, everything would be strictly fixed in the code. Time measures processing speed, FPS, or how long each frame takes, helps to check if the model runs real-time. OS manage file paths and folders, makes sure outputs are saved correctly and paths work on any system. Threading runs text at the same time, like grabbing frames, processing them, and showing or saving them, makes real-time smoother. Typing improves code readability and avoids mistakes, shows that type of input or output function used, which is helpful in big projects. These are the main external libraries we use. OpenCV to get frames from the camera, show image and save output. You can open the webcam, display the GFP-GAN results and save a frame. MediaPipe for detecting faces and key points and applying effects. For example, it finds the face before sending to the GFP-GAN and creates a mask to process only the face. GFP-GAN to restore and enhance face quality. It can take an input frame and give a higher quality output. Now that you know the import, we can start checking the code. The best place to start is the face detector part, because that's where our code begins. This class finds faces in a picture using MediaPipe. In init, it sets up the face detector and you can choose how confident it should be, which changes the detection accuracy. The detect faces method takes an image converted from BGR to RGB, because OpenCV reads BGR but MediaPipe wants RGB. Detects faces and gives a list of boxes around them with X, Y, width and height. Simply put, it looks at the picture, finds all the faces and tells you where they are. This part opens the webcam by default. It uses the laptop camera, but if you have an external or different system, you can change the number to 1 or the right one. It reads frames in a loop and for each frame it detects faces using the face detector. Then it draws rectangles around the faces and writes face on top. The video shows in a window and stops if there is an error or if you press Q. At the end, it releases the camera and closes all windows. The face enhancer class is made to improve face quality, like fixing blur or making it sharper. Model path equal GFP-GAN pre-trained file, which is the path to the pre-trained model. Upscale equal 2, which makes the image 2 times bigger in clear. Upsampler equal none, which is for background if you want to upscale it separately. Then self upscale and self model path are saved for later. And the main engine self.restore equal GFP-GAN is created. Here the options are arch equal clean, meaning the network is lighter and cleaner. Channel multiplier equal to, which controls channels and affects both speed and quality. You can change it depending on your system power. Upsampler equal upsampler. So if you set it, the background will also be enhanced separately. Enhance face. Takes a face image and makes it better. It uses cells.restore.enhance and only keeps the improved faces. If it finds faces, it returns the first one. If not, it gives back the original image. We try to make a face enhancer. It makes image bigger and better. If something goes wrong, we show an error and stop. Then we read the image we want to improve. First, we check if the image is loaded. If not, we stop and show an error. Then we say enhancing face and improve the image. After it's done, we would say enhancement complete. We resize the enhanced image to match the original, put them side by side and show them. Finally, we wait for a key and close the window.